So in this video, we are going to see Arrhenius equation. Arrhenius equation. So Arrhenius equation relates between rate constant and absolute temperature. The mathematical expression is given K is equal to A e power minus E A by RT. So it gives the relationship between the rate constant K and the absolute temperature. Here in Arrhenius equation, K stands for rate constant of the reaction. A is Arrhenius factor. Arrhenius, here E will not come. Arrhenius factor, or you may also call it as pre-exponential factor. Exponential factor. R is the gas constant, universal gas constant. T is the absolute temperature. And finally, EA is nothing but activation energy. EA is activation energy. So now we can derive the expression at two different temperatures to show with change in temperature how it has changed. We can derive the rate constant equation relating at two different temperatures, T1 and T2, from Arrhenius equation. K is equal to A e power minus E A by RT. And here itself I am. So we know that Arrhenius equation K is equal to A e power minus E A by RT. So this is A. Now you take ln on both sides. On taking ln on both sides, this equation becomes ln K is equal to ln. So this I am giving you in the bracket. Later we will expand it to the logarithmic form. So this how you can expand. So this you consider this is in multiple. So if we expand, so we know we have logarithmic expression. A log AB is nothing but log A plus log B. We can expand like this. Similarly here, ln A plus ln exponential minus EA by RT. So we have the equation ln K is equal to ln A plus ln EA minus RT. So we can remove this exponential by taking ln. So ln K is equal to ln A. This will become as minus EA by RT. Right? So we can make this equation as a straight line equation. So how I'm just rearranging this equation. Ln Ka is equal to minus Ea by R I am taking in front, 1 by T plus ln C. If you see this equation, it looks like a linear equation. Y is equal to M X plus C. Right? So M is not It's nothing but minus A by R. And 1 by T is your X, and this is your constant C, and this is your Y. If you plot a graph, so what is the final equation you have? Ln K is equal to minus EA by R 1 by T plus ln A, right? So this is the equation we have that resembles to your linear equation y equal to mx plus c. So if you plot a graph taking 1 by T in the x-axis and your rate constant in the y-axis. So here it represents negative, right? So you will get the negative slope, and the slope value is, this is your slope. Slope value is minus EA by R. And the intercept is ln A, C. C is your intercept. So from this equation, with respect to two different temperature, how it changes. So by differentiating this equation, it is easier. So differentiate this equation d with respect to temperature. Here it is not time, temperature. Ln K minus EA by R d by dt for 1 by T for this, plus this is constant, so it becomes 0. If you differentiate constant, it will become 0. So this equation d ln K divided by dt is equal to minus EA by R. Again, this for simplification, I am bringing this t into the numerator, so it becomes t to the power minus 1, right? So that it is easy to differentiate. So I'm simplifying on the right side alone now. Minus EA by R we have. If you differentiate this, we have t to the power minus 1 and again minus 1. This minus 1 will come into here. Right? So if you differentiate like this, it will come like this. So minus EA by R minus, your minus 1 is there still, t to the power minus 2. So this minus and this minus will get as a plus. So it becomes EA by R into t to the power minus 2. Now you bring this again in this form, 1 by t. Now you have a minus 2. So it is EA by R into 1 by t square. Okay, right? So we have done before integrating the equation this. So earlier we have d ln. So I think we can separate d ln k divided by dt is equal to EA by R into 1 by t square. So this equation we got now. Now it is easy to integrate this at two different temperature. So integrate d ln k before integrating we can separate the variables also. So what is the final equation? D ln k I am keeping here. EA by R is there, 1 by T square is there, dt I am bringing this side from left hand to right hand side. Now it is easy to integrate with the two different limits, T d ln k with, sorry, your lower limit should be K1. So rate constant at temperature T1 will be K1, rate constant at temperature T2 will be K2. So limit will be K1 to K2. Similarly, this side you can take EA by R is constant, integrate 1 by T square into dt. So temperature T1 to T2. T1 is the lower temperature, T2 is the higher temperature. So if you integrate d ln k, it is ln k. So you have limit k1 to k2. And if you integrate here this side, EA by R, minus it will come outside 1 by T minus, right, wait a minute, I may explain. So if you integrate this, you will get minus 1 by T. So we have limit T1 to T2. Here I'm telling you a little faster. So applying the limits, ln k2 minus ln k1 is equal to EA by R. So here if you limit, just I am keeping minus sign outside so that it is easy to understand. 1 by T2 to 1 by T1. Or you can write this bracket like this. Right? So ln k2 minus k1, you can write it as ln k2 by k1. So if you multiply this minus sign inside, EA by R minus 1 by T2 you will get, plus 1 by T1 you will get. So this you can rearrange and write 1 by T1 minus 1 by T2. Take the LCM, EA by R, T1 T2 will be your LCM, T2 minus T1. Right? So finally the equation becomes ln K2 by K1 is equal to EA by R T2 minus T1 by T1 T2. Right? So if you remove this log, the equation becomes 2.303. We are removing ln into log, K2 by K1. Not removing, we are converting ln into log. EA by R T2 minus T1 divided by T1 T2. So finally ln K2 by K1, this I am bringing here, EA by 2.303 R into T2 minus T1 divided by T1 T2. So this is your final equation, or we can call it as Van 't Hoff equation. So from Arrhenius equation at two different temperature, we found the relative or relation between the rate constant and temperature. From this equation we can understand how the change in temperature will affect the rate constant or rate of the reaction. Thank you.